Welcome to the lecture on Chapter 5. We're going to be going over infrastructure and sustainable technologies. Technical architecture refers to the structured process of designing and building a software architecture with a focus on the interaction with software and hardware developers. Technical architecture is a part of software architecture, which focuses on how to deal with certain aspects of software engineering processes. It allows us to better design systems by a couple of factors. First, we can meet systems requirements and objectives. Both functional and non-functional requirements can be prioritized as must-have, should-have, or want, where must-have identifies properties that the system must have in order to be acceptable. And architecture allows us to evaluate and make trade-offs among requirements of differing priority. Although system qualities, also known as non-functional requirements, can be compromised later in the system's development process, many will not be met if not explicitly taken into account at the architectural level. The second way we can design better systems is by enabling flexible partitioning of the system. A good architecture enables flexible distribution of the system by allowing the system and its constituent applications to be partitioned among processors in many different ways without having to redesign the distributable component parts. This requires careful attention to the distribution potential of the components early in the architectural process. The third way we can design better systems is by focusing on reducing the cost of maintenance and evolution. Architecture can help minimize the cost of maintaining and evolving a given system over its entire lifetime by anticipating the many kinds of changes that will occur in the system, ensuring that the system's overall design will facilitate such changes, and localizing as far as possible the effects of such changes on design documents, code, and other system work products. This can be achieved by the minimization and control of subsystem interdependencies. We can also improve system design by the fourth factor, which is increasing reuse and integration with legacy and third-party software. An architecture may be designed to enable and facilitate the reuse of certain existing components, frameworks, class libraries, legacy or third-party applications. So again, in this chapter, we're going to look at MIS infrastructures and building sustainable MIS infrastructures. The chapter explained MIS infrastructure and its three primary types. The three primary areas where enterprise architects focus when maintaining a firm's MIS infrastructure are: first, supporting operations. Information MIS infrastructure identifies where and how important information, such as customer records, are maintained and secured. Second is supporting change. Agile MIS infrastructure includes the hardware, software, and telecommunications equipment that, when combined, provides the underlying foundation to support the organization's goals. And third, supporting the environment. Sustainable MIS infrastructures identify ways that a company can grow in terms of computing resources while simultaneously becoming less dependent on hardware and energy consumption. The book also identified the three primary areas associated with an information MIS infrastructure. These three areas for the information infrastructure that's necessary to provide support for continuous business operations are first, backup and recovery. A backup is an exact copy of the system's information. Recovery is the ability to get a system up and running in the event of a system crash or failure, and that includes restoring the information backup. Second, a disaster recovery plan. This plan provides a detailed process for recovering information or for recovering a system in the event of a catastrophic disaster. Third is a business continuity plan. This details how a company recovers and restores critical business operations and systems after a disaster or an extended disruption. The book described the characteristics of an agile infrastructure. And again, that's going to include a backup and recovery, disaster recovery plan, and business continuity plan. So the characteristics of an agile MIS infrastructure are accessibility, availability, maintainability, portability, reliability, scalability, and usability. Accessibility refers to the varying levels that define what a user can access, view, or perform when operating a system. Availability refers to the time frames when the system is operational. Maintainability or flexibility refers to how quickly a system can transform to support environmental changes. And portability refers to the ability of an application to operate on different devices or software platforms, such as different operating systems. Reliability or accuracy ensures a system is functioning correctly and providing accurate information. Scalability describes how well a system can scale up or adapt to increased demands of growth. And usability is the degree to which a system is easy to learn and efficient and satisfying to use. The book also went in to identify the environmental impacts associated with MIS. And these include increased energy consumption, increased electronic waste, increased carbon emissions that are all associated with MIS. E-waste refers to discarded, obsolete, or broken electronic devices. Sustainable MIS disposal refers to the safe disposal of MIS assets at the end of their life cycle. And lastly, the book went over the three components of a sustainable MIS infrastructure along with their business benefits. The components of a sustainable MIS infrastructure include grid computing, and that's a collection of computers that are often geographically dispersed that are coordinated to solve a problem. Cloud computing, and that's the use of resources and applications hosted remotely on the internet. The term comes, at least in part, from the image of a cloud that's used to represent the internet or some large networked environment. And the third component is virtualized computing, the creation of multiple virtual machines on a single computing device. Okay, now we're at the point where you should take 10 minutes and read the Box Up Your Data case study, and then we'll review that case study when you get back. Welcome back. Let's go over the elements of the box case study. So, you need to list the ways that an agile infrastructure supports Box's business. Well, an agile MIS infrastructure supports change. An agile MIS infrastructure includes the hardware, software, and telecommunications equipment that, when combined, provide the underlying foundation to support the organization's goals. An agile MIS infrastructure includes accessibility, and that refers to the varying levels that define what a user can access, view, or perform when operating a system. Availability, and that refers to the time frames when the system is operational. Maintainability refers to how quickly a system can transform to support environmental changes. Portability, and that refers to the ability of an application to operate on different devices or software platforms, such as different operating systems. Reliability, and that ensures a system is accurate and functioning correctly. Scalability describes how well a system can scale up to meet the demands for increased growth. And usability is how easy the system is to learn and to use. We need also to describe the reasons Box can help a company with its disaster recovery plan and a business continuity plan. Well, a company should have a disaster recovery plan, and this is a detailed process for discovering and recovering information or recovering a system in the event of a catastrophic disaster. This plan includes such factors as which files or systems need to have backups, and their corresponding frequency and the methods of making the backups, along with the strategic location of the storage in a separate physical site that is geographically dispersed. A disaster recovery plan also foresees the possibility that not only the computer equipment, but also the building where employees work may be destroyed. A hot site is a separate and fully equipped facility where the company can move immediately after a disaster and resume business. A cold site is a separate facility that does not have any computer equipment, but is a place where employees can move after a disaster. And a warm site is a separate facility with computer equipment, and this is one that requires installation and configuration of that computer equipment. Box is a key supplier for off-site storage, so customers can easily recover from any type of major disaster, from a fire to equipment malfunctions. Keeping the data at Box is a great way to ensure that company employees can get back on track if the company experiences a disaster. Next, we need to apply the concept of cloud computing to Box's business model. Marketing materials continually promote new technologies that promise to radically change the way businesses operate. Unfortunately, these devices rarely live up to the hype. However, it might actually be true for one new development making this promise. Cloud computing is changing not only the way businesses operate, but also the way people interact with technology. Cloud computing refers to the use of resources and applications hosted remotely on the internet. The term comes, at least in part, from the image of the cloud used to represent the internet. Users connect to the cloud from their personal computers or portable devices using a client such as a web browser. To these individual users, the cloud appears as their personal application, device, or document. It's like storing all of your software and documents in the cloud, and all you need is a device to access the cloud to get access to your documents. No more hard drives, software, or processing power. That is all located in the cloud and is transparent to the users. Companies can use Box to store their cloud data or cloud applications. Box is a key cloud player. We also need to analyze how Box can benefit from a sustainable MIS infrastructure. Sustainable MIS infrastructure identifies ways that a company can grow in terms of computing resources, while simultaneously becoming less dependent on hardware and energy consumption. Sustainable or green MIS describes the production, management, use, and disposal of technology in a way that minimizes damage to the environment. Sustainable MIS is a critical part of corporate social responsibility, and that's the company's acknowledged responsibility to society. There's three primary side effects of a business's expanded use of technology, and these are electronic waste, energy consumption, and carbon emissions. Building sustainable MIS infrastructures is a core initiative and critical success factor for today's socially responsible corporations. And we also need to develop a way that a company could benefit from grid computing using Box. So combating e-waste, energy consumption, and carbon emissions requires a firm to focus on creating sustainable technologies. Grid computing is a collection of computers, often geographically dispersed, that are coordinated to solve a common problem. A smart grid develops and delivers electricity using two-way digital technology. It is meant to solve the problem of the world's outdated electrical grid, making it more efficient and reliable by adding the ability to remotely monitor, analyze, and control the transmission of power. Cloud computing is a utility computing service that offers a pay-per-use revenue model similar to metered service such as gas and electricity. And virtualized computing creates multiple virtual machines on a single computing device. Thank you, and see you with the Chapter 6 lecture.